It's an example of a discontinuous networks. For distance-based, again, I want to stress that here, spatial location is primary. Connectivity is derivative upon it. We will see the exact opposite when we come to the spring mass layout associated with laying out other types of networks. But for distance-based, you have that spatial location being primary. Okay. The key threshold here is the connection range. So if we go from this connection range of 50 on the one hand, so I'm going to terminate that, go back here, and we're going to go from a connection range of 50 to a connection range of 100, what do you expect to see? If people are connected now under a looser criteria, you don't require them to be within 50 units of each other, but 100 units, more generous in connecting people, what do you expect to see? More connections, right. And by extension, fewer components, right? Fewer disconnected components, more giant components that encompass 90% or more. And so indeed, you now have a situation where the infection can propagate more or less through the entire network. That yields a different sort of qualitative situation as far as influence of one individual upon the whole. So the connection range is key here. Yeah. Okay. So for those who are either using the built-in version, the one that I provided, I said you could load, or who hadn't still had that with your model, I'll review that so you could see where it's done, and it's a good review. So so how would I set? Let's reason this thing through. Where would the size of that oval associated with a person be set? It's in person. It's not in main. Main is just the stage. So it's in person. And where is it in person? Okay, yeah, so it's among their attributes. So let's double click, we'll get to person. Okay, yeah, and specifically, the reason that appears on the screen is because we have a sort of a graphical object defined associated with this person, and it's up here in the upper left. We added it the first day, I think. And indeed, it's in the dynamic properties for it. Exactly right. And specifically, if you go to the radius X, radius Y for the person, you can see that that's specified here as the income is specified as defining the radius. Okay, so I have income divided by 2,000. That is why it shows as different sizes, because there's heterogeneity in income. Okay, and why is there heterogeneity in income? Where is that defined? Who remembers where that was defined? That was a parameter, and that parameter and the distribution associated with it was specified where? That's right, in the population which lives in Maine. That's right. So if we go up to Maine, you go to the population here, you will see that income was defined as being drawn from this distribution. Okay, that's defined in the population rather than in person per se, because it might differ for different populations. And by a parameter, we allow the folks responsible for creating this population to dictate its characteristics. The parameter gives that conduit of communication between, on the one hand, the context in which it's created, and on the other hand, the object itself, the agent itself. Okay? So that was kind of a recap for why they're different sizes. Now, incidentally, if we had gotten rid of that income divided by 2,000, left it blank, they would have been just the default size for person. So they would have appeared all uniform size, this size. Okay? Does that make sense? Okay, so great question and review. Okay, so let's go now to take a look at, so we saw this. Now let's take a look at a different network type, okay? We're going to take a look at a network type where, again, we have locality. In fact, we have arguably even more locality. But the locality here is not spatially based. It's based on sort of logical locality of different agents, okay? So we're going to look at what's called a ring lattice network. And this is a network which exhibits purely local connectivity, and agents are in a sort of one-dimensional structure. Not a 2D as is used for a distance-based layout, but a one-dimensional structure, a long chain where the one exception is the people on the two ends of the chain are connected to one another. So it's a big ring, okay? The one ring that binds them. And we're going to see how that affects the dynamics. So let's go back to our model here. And